Hi, Assalamualaikum. My name is Fatihah Zulaikha binti Fauzi. My marriage number is AA222139. Today I would like to talk about torsion. The shaft in smart solar grass cutter is used to transmit power from the motor to the wheels. So can we find the maximum shear stress that has developed in the shaft? So we imagine that the power in smart solar grass cutter is 2.5 kilowatt. The end is 200 rpm and the diameter is 0.08 meter. So from as we know in torsion, we must to conclude the J. So the formula of J is pi d power of 4 over 32. So from that we get J is equal to 4.021 multiple 10 power of negative 6. So next we can conclude we can calculate the angular velocity. So we get 20.944 radian per second. So from power we can calculate the torque. So we have the power, so the power is 2.5 kilowatt and the angular velocity is 20.944. So we can calculate the T. So we get the torque is 119.995 Newton meter. So from that we have the all informations that we can calculate the maximum shear stress. So from that the answer is 1.19 megapascals.
Assalamualaikum. My name is Mohammad Haziq bin Akmal. I'll be continuing the problem regarding shear stress. As we all know, shear stress can be calculated using the formula T equals to F over A, where F is the applied force and A is the cross-sectional area over which the force is applied. For our question, let us assume that the box has a dimension of length 2 meters, width 1 meter and height 0.5 meters. So in this example, the load P is equal to 1000 newtons evenly distributed over the top surface. The cross-sectional area A is calculated as L times W equals to 2 meters times 1 meter equals to 2 meters squared. The shear stress is then can be calculated using the formula resulting in 500 pascals. So what are the discussion for shear stress? First and foremost, force distribution. The shear stress formula assumes that the force is evenly distributed over the entire cross-sectional area. This is a common assumption in introductory mechanics. Second, units. Shear stress is expressed in pascals, which is equivalent to Newton over meter squared. It represents the force per unit area. Next is material response. Understanding shear stress is crucial in material science and engineering, as it helps assess how materials respond to applied force parallel to their surface. Excessive shear stress can lead to the formation of failure. And lastly, real-world application. Shear stress calculations are used in various engineering fields, including civil engineering for structures like beams, mechanical engineering for analyzing materials and components, and lastly for fluid mechanics for understanding the flow of fluids. In summary, shear stress is the discussion of considerations of force distribution, unit analysis, its significance in material behavior, and its application in a real-world engineering scenario. Thank you.
Assalamualaikum, my name is Davik bin Edi Tan. My number is AA220291. So for the bending moment, the question is rectangular box with dimension L equal to 4 meters and applying load P is 10 kilonewton applied vertically at the center of the top surface. So for this question, we use the formula mx equal to P over 2 multiplied by x multiplied by L minus x. So x is 2, so P is 10 kilonewton and x is 2, so it's 10 kilonewton divide by 2 multiply by 2 multiply by 4 minus 2. So we got M2 equal to 5 kilonewton multiplied by 2 multiplied by 2. So the result is M2 equal to 20 kilonewton per meter. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Muqaffa bin Azman. So the next main component is the power transmission. The question is, the shaft in the diagram below is used to transmit power from the motor to the wheels. Find the power transmission from the motor to the wheels when the torque is 120 Nm and the national speed is 200 rpm. So the formula for power transmission is P equal to T multiple angular velocity. So the angular velocity formula is 2 pi divide by 60 multiple n. So the n is given, which is 200 rpm. So 2 pi divide by 60 multiple to 200 and we get 20.94 rad per second. So from that we proceed to find the power, which is torque multiple to angular velocity. So the 120 multiple to 20.94 and we get the total power, which is 2.5 kilowatt, and that's it. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afiqah, binti Mohsein. My metric number is AA221520. So the question for centroid, combining a solid circle with a circular hole in the middle creates a wheel. The radius of the inner round hole is 4 units, while the radius for the outside circle is 8 units. Determine the composite wheel shape centroid. To answer this question, we need to find the outside and inside circle area first. For the outside circle area, since the area's formula is A equals pi r squared, outside circle area's radius are A, so we will get 201.06 unit squared. For inside circle area, the radius for the inside circle area is 4, so the answer will be 50.27 unit squared. The total area are 150.09 unit squared. For the central x coordinate, we will get 0, and the central y coordinate, we will get 0 too. So the origin 0, 0 is where the center of the wheel form occurs. Thank you.